Good morning, class. This is G. Suryachandra Swami from Setam Engineering College, Vijayanagaram, Gazalrega, and from the Department of Mechanical Engineering. Today, we are going to discuss about the gearboxes in automobile engineering. Before starting up with this topic, we are going to discuss about the introduction and the purpose. For what purpose we are doing this? The purpose of this gearbox is to provide speed and torque conversion because of limitations of internal combustion engines. We are having so many limitations in the internal combustion engine, so for that purpose, we have to increase speed and torque everything. So we have introduced this gear shafts. Next, it's also used for facilitates changes of direction of output shaft for reversing. For reversing the output shaft, we can use this gearbox, and also automobile gearbox are used to reduce load on the engine by manipulating torque and speed. By manipulating this torque and speed, we can also reduce the load. Uh, they have these options to select one several different types of gear ratios. We can discuss in next slide. In the next slide, what are the different types of gear ratios are there. Once the engine has reached a number of revolution per minute (rpm), it is advisable to increase the gear to reduce the engine rpm to reduce the wear of the engine. So for this purpose, we require a gear shaft. Okay, and it is also used to allow more control and greater speeds, and it is also used for better acceleration and better fuel economy also. Okay, next, the most gearboxes are used to increase the torque and reduce the speed and of the output shaft. Okay, this produce the mechanical advantages also. Automobile gearboxes also have to have the provision to do the opposite, that is to provide increase in the output shaft speeds with reduce of the torque, as we had discussed right now. uh, the next topic is the basics of the basic principle of the gearboxes. These are the two gearboxes. One is a spur gear, and another one is helical gear. In this spur gear, the interesting thing is that the most basic type of gearbox is spur gear, and it has a straight cut teeth. It is having the straight cut, and this cut is very straight. No? That's why it's called the spur gear, where the teeth are cut parallel to the axis of the gear. Uh, this will cut to the parallel to the axis. This is the axis of the gear. This will cut to the parallel to this axis. That's why it is called a spur gear. Next thing is helical gear. This helical gear, winder gears are these are the gears which are used for wider, and those are cuts are smoother meshing are cuts. This is the smooth meshing cuts with the teeth of an angle. This is having some angle. If it is having some angle, then we can call it as a helical gear. Okay, this is the difference between the spur gear and helical gear. Um, the next thing is the basic principle. Because of the angle of cut, helical gears teeth have much more gradual engagement with each other. It will be engaged more with each other, and they operates more smoothly and quickly than the spur gears. Well, compared to spur gears and helical gears, helical gears operate very smoothly and quickly well compared to the spur gears. Helical gears can transmit more torque because at any time more number of teeth are in mesh. Yeah, for the same thing for helical gears, at one particular time, one gear will be in the mesh or two, three gears will be in mesh. But for the helical gears, because of this structure, at a time, one, two, and three, and four to five gears will be in mesh with each other. For spur gears, it is only having one gear which are in mesh with each other. This is the difference between the spur gear and the helical gear. The gearboxes for cars and motorbikes almost always use helical gears only. Okay. However, helical gears also expect undesirable axial thrust. This is very most interesting thing. To prevent this axial thrust, double helical gears are used to prevent for this axial thrust, which can be cancel out this thrust. If you use the double helical gear, we can cancel the axial thrust. We can avoid this axial thrust. Okay. The next thing is the principle. And the principle is collection of helical gears in the gearbox gives the gearing down the speed and the engine crank to final speed of the output shaft for the gearbox. We find a total for the gearbox, which is it is going to explain. And these are the typical examples for gear ratios for 5-speed manual gearbox. For the first speed, the first gear for the first gear, the ratio is 3.116 to 1. That is the gear ratio, and the RPM maximum for the first gear, the RPM is 947. Okay, for the second gear, we can see it is very less when compared to the first gear. The ratio is 1.882 to 1, and the RPM is very higher than the first gear, that is 1594 RPM. And the third gear, it is very less than the second gear. We can see here clearly for the second gear, the third gear, and the fourth gear, if the gears are increasing, the ratio of the gear speeds will be decreased, as we can see here. If the gears increases, the RPM will increase. You can see for the first gear 947, the fifth gear 4065, which shows a very high RPM. With that high RPM, they are rotating. Okay, this is the gear speed manual gearbox. And these are the types of gearboxes. There are so many types of gearboxes. We can see sliding mesh gearbox, constant mesh gearbox, synchro mesh gearbox, transaxial gearbox, sequential gearbox, automatic gearboxes. In this, we are going to discuss about sliding mesh gearbox today. Okay, this is the simple pictorial diagram for this sliding mesh gearbox, and we can see clearly this is the main drive shaft. This one is the main drive shaft, and this one is the counter shaft. These are the two shafts. This is main drive shaft, and this is a counter shaft. And this one is the main shaft. This is the main drive gear. Sorry, this is the main drive gear, and this is the main shaft. In this shaft, the main gear is located. The main drive gear is located, and this is the counter shaft. Okay, the first gear, we can see here the first gear. This is the first gear, and this is the second gear, and this is the third gear, and this is the top gear, as we can see here. Okay, normally three forward and one reverse gear ratios are there. For the in this, we are using spur gears only. Gear wheels on the main shaft are engaged with the gear wheels on the lay shaft. This main gear wheels on the main shaft will be engaged with the gear wheels on the lay shaft by sliding themselves like this. It will slide, and I will show clearly. Now, and this sliding mesh gearbox not used in the nowadays presently. Okay, this is the sliding mesh gearbox. This is the main shaft. I have already told you. This is the counter shaft, and these are the gear arrangements. Okay, this is first gear, second gear, third, fourth, fifth, sixth, seventh, eighth. These are the 8 gears we can see here. Uh, what happened if you apply the first gear? We can see it clearly. If you apply the first gear, what is going to happen? uh, uh, these 6 and 5 are in contact with each other. As we can see clearly, 4 and 3 gears are not in contact with each other, but the clutch shaft and the counter shaft will be in contact, but they this is not in contact with each other. The clutch shaft and the fourth gear are not in contact with each other. We can see clearly here. And this eighth and seventh one will be in contact with each other, but eight is not in contact with the main shaft. We can see here clearly. This is going to happen while we apply for the first gear. If we apply the first gear, then what is going to happen? The 6 and 5 gears are in contact with each other, and 3 and 4 are not in contact with each other, and the remaining all the gears will be in contact with each other after the applying of first gear. What will happen if we apply for the second gear? After the second gear is applied, it slides. This gear will slide in this way, and that 4 and 3 are will be in contact with each other, and the 5 and 6 and 5 are not in contact with each other. And as usual, 8 and 7 are in contact with each other, and 1 and 2 are also in contact with each other. But this 1 and 4 are not in contact with each other after applying the second gear. What is going to happen if we apply for the third gear? If you apply for the third gear, what is going to happen? This main shaft, as we see in the earlier, here there is no contact between 1 and 4, but after applying the third gear, the 1 and 4 will be in contact with each other along with the counter shaft. This is the counter shaft, that one is second one, and these three all be in contact with each other, and remaining all are in disconnect with each other except this 8 and this small gear, 8 and 7 gear. Okay, this is for the third gear position. And what is going to happen for the reverse gear? This is the reverse gear position. If we apply for the reverse gear, then everyone is in disconnect with each other. This 1 and 4 are disconnect with each other, but 1 and 2 are in contact with each other. After that, and this 4 and 5, this 4 and 3 are also in disconnect with each other, and this 6 along with this 8th gear along with the 7th gear are in contact with each other. After this, the reverse gear will then this the reverse gear will be applied. Okay, class. I think this is clear what is going to happen in the sliding mesh here. Uh, okay, thank you.